All right, welcome to lesson 4.6, and as you can see, tonight's lesson is on rational numbers. Now, rational numbers is comes out of a whole series of discussions that I like to call how numbers evolved. So from primitive times, where numbers would have come from. And so I call this lesson Caveman Math. And as you can see, Ben is going to be helping me out with this one again. Yep. So let's talk about where numbers, Ben, would have originally come from. So let's say Caveman walks out of the cave. The very first thing Caveman probably would have done would have been notice things around them, and they probably would have started counting them. So let's say they walk out to an apple tree, and they made up symbols and names for 1, 2, 3, and so on. Okay? And so that's called the counting numbers, or sometimes we call those the natural numbers because they kind of naturally occur. Okay, and so that's the first set of numbers that probably existed back in prehistoric caveman days. Now, it seems silly, but let's say the caveman goes out to the tree, and after a couple days he's eaten all the apples off the tree, so now he realizes that there are 0 apples on the tree. Yep. So we can't really count 0 of something because you had to already have something to know that there now are 0 of them. Yeah. So that's actually a more complex concept. So we actually rename the set when we add 0 to it, and notice it's still basically the same set, we just added 0. So it's 0 plus 1, 2, 3, 4, 5. So when you throw 0 in, the counting numbers become the whole numbers. Yep. All right, now at the very beginning of the year, the next thing that we could have happen to our caveman, let's call him Nog, is Nog could eat all the apples on his tree, and then he could go next door and he could borrow some apples from somebody else's tree and eat those. Well, now the person he borrowed them from wants them back. So now Nog has just stumbled into the idea of what kind of numbers? Negative. Right. And so we started out the very beginning of the year with things like -1, -2, -3. And do you remember what those are called? When you have the set of positive numbers, 0, right. That's called the set of integers. Now, all the ones we already have, all the counting numbers and 0 are integers, but now we're also going to add all the negative numbers. Okay. Now, again, what was the opening slide? We were supposed to be talking about rational numbers, right? Mm-hmm. Well, let's say Nog has 3 trees on his apple, and he goes out and he picks an apple, and he only eats half of it. Well, now he's got something like 2½ apples left. Or maybe he eats most of the apple. He's down to his last apple, so he's taking his time, and so he only eats 1/4 of that apple, 3/4. You could also have negative. Suppose he borrows half an apple from his neighbor. So all of the numbers that can be written as mixed numbers, positive or negative fractions, these are the set, and this is what we're talking about tonight, of rational numbers. Now, I'm going to start writing rational with red, and then I'm going to switch to black. To emphasize, what are the first 5 numbers, or first 5 letters in the word rational? Ratio. Ratio. And ratio, as you know, is really just another name for a fraction. Mm-hmm. So what a rational number is, let's go to the definition now. What a rational number is, it's any number that can be written as a fraction. Okay, so a rational number is a number that can be written as a simple fraction. Well, that begs the question probably, what do we mean by simple fraction? Well, a simple fraction is a fraction where we have an integer on the top and we have a counting number on the bottom. Okay, so we're not talking things like 3.5 over 2. And if we want to have a negative fraction, let's just put the negative part on top. Yep. So why would we have a counting number on the bottom instead of a whole number? Well, counting numbers don't include what number? That would be in the whole numbers. 0. Right, 0. We don't want to divide by 0, so by making it a counting number, we never have to worry about having 0 on the bottom. Yep. So we basically have a counting number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to infinity, something like that on the bottom, and something similar to that on the top, although the top can also be 0, and it can also be negative. Okay, so it's an integer divided by a counting number. And if there's a way to write the number like this, then it's a rational number. So obviously 3/4 is a rational number, but what about 5? Can you write 5 as 5 over a counting number? Sure. Just write it as 5 over 1. Or you could write it as 10 over 2, right? Mm-hmm. There's lots of ways to write it. How about the number 3.3? Well, again, yes, because we can write that as 3 3/10, right? Yeah. And 3 3/10 is the same thing as 33 over 10. It's also the same thing as 66 over 20. there's actually an infinite number of ways to write any rational number as a fraction. So if there's a way to write it as a simple fraction, it's in the rational numbers.
Yeah.
So you might think, well, wait a second, isn't that everything? Well, no, because what if you have something weird like square root of 2 or square root of 3 or pi? Those are numbers that cannot be written as simple fractions. Sometimes we use 22 over 7 to approximate pi, but it's just an approximation like 3.14. Yeah. It's not the exact value.
It's not real.
Right. Now another way to look at a rational number, if you look at how rational numbers are as decimals, all right, well, let's think about the kinds of decimals that can be changed into fractions. Well, the ones that terminate,
like
so things like, well, yeah, 1/4 is already a fraction, but something like 3.3 or 0.25, okay, is the same thing as 1/4. So any terminating decimal, also any repeating decimal, turns out that there's a way to change those into fractions as well, and we're going to be talking about that as we move forward in this. Okay? If we're graphing rational numbers, we're talking about putting them on a number line. All right, sorry, I had to pause the video. I had to sneeze really, really, really loud. I think I just scared Ben or Nog or whoever this is sitting next to me. But if you have a number line, we should be able to put things like 1/4, 1/3, 1/2 in order. And so sure enough, if we went from 0 to 1, if all of the tops are 1, well, the smaller the bottom number, the bigger the fraction. So 1/2 would actually be here, 1/3 would be about here, and 1/4 would be the smallest one because we're getting the same number of pieces, but they're smaller, exactly. Now in negative land, it's the opposite. Okay, so negative 1/4 would be the biggest fraction. It'd be right here. Negative 1/3 would be about here, and negative 1/2 would actually be the smallest fraction. Just remember, everything reverses when we're in negative land.
With negative.
Yep. Okay. Now we can also evaluate rational numbers. Sometimes these things are going to look like equations. So you might have something like x minus y over 5. All right. And if x is equal to 7 and y is equal to, I don't know, 14, then we would get what? 7 minus 14 over 5. 7 minus 14 would be...
7/5.
Would be negative 7 fifths. And then you can leave it as a fraction like that, or sometimes when we have improper fractions, we change them into mixed numbers. Okay, so there's lots of cool things that we can do with rational numbers and with rational expressions. Oh, look at that. Good catch.
It's wide.
Now, see, everybody watching this video is going to be mad at you because if they had caught that, they would have been able to get a bonus point. See, this is why I have people help me with the videos, to keep me honest. I think that's basically what we want you to know for tonight to get started with rational numbers. Obviously, the next couple sections we're going to be doing a little bit of fraction math, so this is just a good introduction. And again, remember, especially for your daily quiz tomorrow, the different sets of numbers. Yeah. So the counting numbers, or the natural numbers, the whole numbers, the integers, and then finally the rational numbers, which include all of these. Right. And then, by the way, I do have one more thing while we're looking at this screen. If a number cannot be written as a rational fraction, as a simple fraction, then we call it irrational. Now, irrational doesn't mean it's crazy and you can't talk sense to it.
Like
right. What it means is you cannot write it as a rational number. All right, so we're going to wrap this up. Let's see, final slide. Let's go back. Let's put that crazy picture of
Nog.
Of Nog. Yeah, there we go. There we go. Nog's happier now that Nog knows a little bit of math. So there we go. So, yep, we're going to go ahead and stop now. Thanks for watching, everybody, and we'll see you in class tomorrow.